And so let me show by hand. How about I show by hand first, and then we'll do it by calculator, and you can do it either way on the test. So we're in this new world, matrix world, where we're putting numbers in boxes, right? So we got a bunch of numbers in a box there. Remember, math is made up. Math is all just totally made up to do things that are in the real world, right? So they just made up, they just said, hey, how about if we put these numbers in boxes? Could we use that to do something? And it turns out there are, you can type into Google real life uses of matrices, and you'll see all kinds of different things they do. I think they made them up in the 1700s or 1800s. Anyway, whatever. Google will give you all the history you need to know. Let's get to cranking it out. So it's a whole new thing. So that's the point I want to emphasize. It's a brand new thing. Numbers in boxes, matrices. You are here. Okay. Good. All right. So, yeah, let's, all right. So we will zoom. Matrices. All right. We're talking about these numbers in boxes. So, we gotta make the rules for these things. It's like a brand new world. Matrices, they made them up, and they made them up to do real life things, which we'll see later. But first off, they have to make the rules for these things. Meaning, how do you add them? How do you subtract them? How do you multiply them? And how do you divide them? How do you add, subtract, multiply, and divide these numbers in boxes? So, called matrices. Well, you tell me, if you were to make up the rules for adding A and B there, like, I guess we're supposed to subtract. Okay, well, I'll do subtraction, whatever. How would you make up the rule for subtracting matrix A, take away matrix B? What would you do? Would you, add all these up together? What would that be? 1, 2, 3, 4, 5, I think. 7, 3, 6. That was 6. And then add all these up. No, you wouldn't do that, would you? I mean, but that'd be one possible way. Do you realize? Maybe I want to make clear that there's options here, right? You don't have to do what I'm sure is in all your minds. What is in all your minds? Aren't you thinking, well, you go entry by entry. Like upper left, take away upper left. And you're exactly right. That's the rule. That's what they came up with also. You just take 0 minus 6, right? Upper left minus upper left. And you take upper middle minus upper middle. 5 minus 1. And you take upper right, minus 4, minus 0. Take lower left, minus 1, minus 5. Middle, lower, 1 minus 7. Middle right, 3. Careful there, minus and negative 2 going to be plus, huh? So I'm subtracting matrix A, take away matrix B. What do we get? Negative 6, 4, negative 4, negative 6, negative 6. And that's going to be 5, huh? And that's the answer. So that is what they came up with, which seems very natural, huh? That seems like the most natural thing to do. And that is exactly what they did. Samantha? Did I mess up? Oh, thank you. 1 minus. Oh, yeah, I totally messed that one up on both accounts, huh? Yeah, thank you. This one's wrong, huh? It is 1, take away, negative, so it's add, so it's 6, huh? Are the rest right? Makes sense? That's real natural. That's exactly what they did. They don't always do what's real natural. We get to multiplying, they're going to do something weird. But so far, they made up rules that I think we would all make up, Just go entry by entry, right? Just subtract, upper left, etc. That's the rule. That's how you add and subtract matrices. Very much like you would expect. Now, could you guys do this on your calculator? Well, let's do a harder one on the calculator. This one's so easy, it'd be better just to do it by hand, So there's the answer. You just type those into these 6 boxes, and we've got it. Good on that so far? And we're going to multiply a matrix by a number. So here's matrix B, and they're saying take 6 times matrix B, 6 times the 5, 1, 0, negative 2, 1, negative 5. Okay. If you were to make up the rules on this, how would you make up the rule of multiplying a number like 6 times a whole matrix? What would you do? Exactly. You just distribute to everybody. That's exactly what they came up with. You just distribute to everybody. So it's 30, 6, 0. What's that? Negative 12, 6, negative 30. If you have a constant number multiplying a matrix, you just multiply everything inside the matrix. Very natural. So far, so totally natural, huh? Like I said, they're going to get weird on us. in a little bit, they're not going to make multiplying like you would expect. But, I mean, multiplying two matrices. But a number times a matrix, just what we would expect. Maybe not. Maybe prefer to do it by hand. Whatever. So here we go. So now they're telling us, take 2 times matrix A and subtract 4 times matrix B. So you know how to do that, right? Just multiply 2 times the matrix A. Maybe I'll just do it by hand here. So 2 times this guy, what's that going to be? Well, not 2. I'm multiplying by 2. So that'd be 0, 2, negative 10, 2, 6, 8 for the first one. Take away, then 4 times matrix B would be 12, 4, 0, negative 16, 4, negative 16. To do that right. And now we subtract them. And so that's entry by entry. 0 minus 12 be negative 12. 2 minus 4 be negative 2. Minus 10 minus 0 is minus 10. 2 minus 16 is actually add 16 is 18. 6 minus 4 is 2. 8 minus a minus 16 is add 16. It's at 24. I think I got it. Is that okay? So it's quicker by hand probably for these ones. In a bit, it's going to be better to use our calculator. But so far, by hand is, I think, better. Questions on that? Everybody see what I'm doing there? Just multiplying and subtracting? All is well? Can I move along? Actually, before we do, let me go back again. I'm going to backtrack for just a minute before we do the new one. Let me backtrack for just a minute. And we already, you would know how to add A and B, right? You just add them entry by entry. You know, real natural, real natural. Let me ask you this. What if matrix A was, well, let's just keep matrix A the same. And what if matrix B only had part of it, like didn't have the whole thing? Was just like, let's say, 5, 1, negative 2, 1, just a 2 by 2. How would I, and what rule would you come up with for adding them then? Like, what if they're different sizes, in other words? Because there's all kinds of sizes of matrices, huh? So what if matrix A and matrix B were different size matrices? How would we add those? What's the rule for that? Just stick zeros in the blank spots? Yeah, like over here and here, just put zeros. And even if it was, like what if matrix B was 5, negative 2, 7 was like further down? Let me change the game. So that's Alberto said, like, just put in zeros. That could be. But let me push it a little bit more. What if that was matrix B? What if it was what are you gonna do now? Still zeros? Where would you put the zeros? Like here? And here? But B is actually further down than A. Oh, just boom like this and zero. Just fill them in until they're the same size with zeros. I mean, they could have done it that way. They didn't. But they could have. That's not a bad thought. Yeah, you could always just add in zeros until the things are the same size and then add them up. They totally could have done it that way. They did not. They did something else. But that's a thought. I guess they didn't find any real life use for that. So they didn't do that. What did they do? Does anybody know? How do you add matrices that are different sizes? Done a little bit of matrices in another class? Nobody knows? They said, don't do that. There is no rule. You cannot add matrices that are different sizes. They said, don't do that. Don't add them. Don't subtract them. They saw no real life use for ever adding or subtracting matrices that were different sizes. That will not be the case for multiplying. We will multiply matrices that are different sizes. We'll multiply them, but we will not add them nor subtract them. They just said, don't do that. There's no use in adding or subtracting matrices that are different sizes. You probably wish they would do that more often, huh? Just say, don't do that. Okay, so now we're to multiplying. They want me to take matrix B and multiply matrix C. All right, this is going to be weird. It's not going to be as you would think. First off, notice B and C are different sizes, huh? And they can be multiplied, it turns out. In fact, sometimes same-size matrices may not be multiplied. We'll see the story. All right, so B and C. First thing you need to know is you got to get the sizes down. So here we're multiplying now. It's a whole weird world. multiplying matrices. So, first off, the sizes. Whenever you do the size of a matrix, very important, it's down first, then across. It's the opposite of graphing. You know how when you graph, you always go X is over first and then Y is up, down? It's the opposite for matrices. It's down first, then across. So matrix B would be a 2 by 3 matrix. And what is the size of matrix C? 3 by 2. It's 3 down, 2 across. So matrix B then is a 2 by 3. And matrix C is a 3 by 2. Does that make sense? It's always down first, then across. Okay, now why is that such a big deal? Because the inside numbers must be equal or you cannot multiply. See these two numbers? They have to be equal. Not the outside numbers, but the two inside numbers must be equal. And they are. So this one's a go. This one's a green light. You can do it. But if they were not, if those inside numbers are not equal, you cannot multiply those matrices. So it's not that they have to be fully the same size. They don't. But the inside numbers must be the same size. Okay, so that's important. Now, the answer size will be the outside numbers. So in this case, that's the 2 and the 2. The answer matrix is going to be a 2 by 2. That's why they're setting up BC as a 2 by 2 for us. See how they're doing that? They're saying the size is going to be a 2 by 2 because those are the outside numbers. So the inside numbers must be equal to be allowed to multiply the matrices, and then the outside numbers tell you the setup, the size of the answer matrix. It's going to be a 2 by 2 right there. Okay, so let's do the 2 by 2 thing, and let's find the answer. So that's just the size. That's just the setup. Now let's find the actual answers to it. How do we actually do that? Well, it's kind of a weird thing. Everybody got that copy done? I'm going to go to a fresh screen because it's a weird thing. You're probably going to want to use your calculator. I'm going to show you by hand a couple times, and then we'll do it by calculator as well. So B times C, let me write it down here. 3, 1, 0, minus 3, 1, minus 3, and 4, 4, minus 2, 1, 4, 2. Okay, so like we said already, the answer is going to be a 2 by 2. So I'll just kind of set it up. It's helpful, I think. Now, here's how it works. Nobody's done this before? The left hand goes across, the right hand goes down. You've got to go different directions. So you start right here, and you start right here. And as you multiply, you multiply the numbers, and then you jump. So your left hand is going to be going across. Your right hand's going to be going down. You're moving your hands like this. Left hand across, right hand down. So 3 times 4 plus, it's times there. 3 times 4, it's going to be 12, but I'll figure all the numbers out in a minute. Then you jump. 1 times 4. See what I did there? My left hand, so I multiplied 3 times 4, and then my left hand jumped, my right hand went down. Every time. You multiply, jump. Multiply, jump. Right? You just keep multiplying and jumping. 1 times 4 plus 0 times negative 2. So that all becomes what? 12 plus 4, that's a 16. So the first entry among the 4 entries in the 2 by 2 answer matrix is a 16. That's just one answer. I got 3 more to go. Everybody see what happened there? So my left hand's moving across, my right hand's moving down. And I just multiply, multiply, multiply as I'm moving. See how those all came about? Now, let's go down to the bottom row, and we'll restart again with the first column. How do you know? It's bottom left. This area is the bottom left. Do you see where your arrows are starting tells you the entry you're about to find? You can do these in any order you want. I do bottom left to get the bottom left entry. When in a minute, I'll move over here, and I'll do bottom right, and that'll be the bottom right. And then I'll go up here and I'll do top row right. That'll be upper right. You see that? Wherever you start and then boom, 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 that tells you where that answer ends up going. Kind of weird, huh? This isn't how you would have made this up, huh? Right? They made it up. Wouldn't you just say, look, just do entry by entry like we did for adding? They made up a totally weird thing because it's useful. You'll see some real life situations where it's actually the useful thing for real life purposes. Anyway, so like I told you, it's weird. All right, so let's go back to it. So I'm going to go bottom left. Here we go. -3 times 4 plus 1 times 4. And then -3 times -2. That's kind of scribbly here. So what is that number? -12 plus 6. Is it -2? Did I do that right? Okay. So we got 2 answers out of 4. You see why this will be better on a calculator, right? Calculator will do it for you automatically once you got it all entered. So far so good though? Everybody see what's going on? Can I answer questions on that? So let's do the upper right. So now I'm going to do the upper right. So everybody see where I'm going? So I'm going to go across the upper row and down the right. So my answer is going to go in the upper right. So here we go, upper right. So 3 times 1. 1 times 4. You add in between these. So 3 times 1 plus 1 times 4 plus 0 times 2. And what's that? 3 plus 4 is 7. Good there. Finally, the lower right. Go across the bottom row and the right. It goes in the lower right. So I'll get, where are we going? So lower right, so -3 times 1. And 1 times 4. -3 times 2. Is that on the screen? Yeah, okay. -3 plus 4 is 1. Is it -5? I think I did that right. So there's our answer. It is 16/7 minus 2 minus 5. It's a 2 by 2. Questions I can answer. Well, I'll leave it up. Let's do it on a calculator, huh? You guys got your graphing calculators? You'll like that better. Thank you. So, do you remember how to enter a matrix? Yes. So go ahead and put matrix B. We're doing B and C, huh? Put matrix B in the B slot and C in the C slot. It doesn't really matter where you put them, but I'll just stay with the same letter. So let's do that. So enter those in. I'll write out, well here, maybe I better, if you got that copied down, everybody got that copied down, I'll write out the instructions for entering the matrix again. If you didn't get that, look on the YouTube later. So basically, the instructions are like this. So type in, what do you type in? You hit second. So first off, let's enter B. So you got to hit second, x to the -1, right? Yeah, which is the matrix key. Second matrix. And, yeah, in fact, I should send to YouTube. Let me make myself a note. Because, there's good YouTubes out there. I sent one to somebody just yesterday. I'll just send it to all your emails that you entered into Math Excel. Whatever email you put in there. I'll just send you an email, YouTube link on matrix operations. So you'll have somebody walking through showing the exact button pushing and everything. Anyway, so let me write it out. So hit second matrix, and when you do, you have to go go across twice to edit mode, and go down to B, and then hit enter. And then, right? Yeah. And then you want to enter the size. Matrix B is a 2 by 3. So hit 2 by 3 for the size. And then enter B and hit second quit, which is just above the mode key. All right, that enters B. And then enter C the same way. And then after you've got B and C put in there, then you go now to multiply. You hit second matrix again, and you're under names. You go down to B and hit enter. Then you hit second matrix again. On names, you go down to C. Well, and I forgot the times. Hit times in between. Then second matrix names down to C and hit enter. And then hit enter one more time. There's the steps. So if you go through those steps, now I'll show it on the overhead in just a second. If you got that copied down, there's the steps for doing it. Everybody getting that down? That's for a TI anyway. That's for a TI. So I'll send a Casio. How many people have the Casio? Just one, okay. Oh, 2, 3, okay, a couple of you have it. Yeah, so it's probably similar, a little different. I'll see if I can send a Casio YouTube as well. Casio's great. It's cheaper. Sometimes it's easier, actually. I don't know why the TI dominates the market. Anyway, everybody got that copy down? So I'm going to go over to the showing the actual steps. So here we go. So, all right, so here, let me go back to me. So here I am on the blank screen. Hit second matrix, see the matrix down here over the X to the -1 key? Hit second matrix. I'm in the matrix mode. Remember this? We've seen this before, haven't we? Has the little menus at the top, names, math, or edit, depending on what you're trying to do, right? So I want to go over to the edit and go down to B. See how I'm on edit matrix B, which means like entering it into a Microsoft Word document or something, right? You're going to type it in and save it. So I'm going to edit matrix B, hit enter. Now I got to put in the size. What was B? It was a 2 by 3. 2 down, 3 across. Hit 2 by 3, enter. It sets up a 2 by 3 array for you. Now just hit all the numbers and enter. So I'm going to go 3, enter, 1, enter, 0, enter, -3, enter, 1, enter, -3, enter. So there they all are. I hit enter. Every time you hit enter, it saves it right then. So it's all saved. You can turn off the calculator if you want. It's got it. I'm going to hit second quit to go out. It's got it saved. Second quit. Now I got to put in matrix C. So go back into matrix, second matrix, back into the matrix. Go over to edit, down to C this time. Hit enter. Matrix C is a what? 3 by 2. 3 down, 2 across. And then put it in. 4, 1, 4, 4, -2. Make sure you use the right negative. Remember, the calculator doesn't like subtraction instead of negative. So the negative has the parentheses around it. So there we go. I hit enter with each one, so it's got it saved. Hit second, quit. I've now got matrix B and matrix C saved in the memory banks. So now go back into matrix mode one more time to multiply them. And you want to name it. To name it is like to call it forth, to bring it forth onto the main operating screen. So I'm going to name, I don't want to move over at all. I want the name menu down to matrix B. So go down to matrix B, hit enter. There it is. It says, all right, B. What do you want to do with B? I want to go times. I just hit the normal old times button. B times. Then go back to matrix menu again. Second matrix. Name C. Go down to C. Enter. B times C. Enter one more time. There it is. Much easier than all the painful work we went through. That answer. So there's the steps. There's the answer. What was that answer again? It was 16 minus 7? Positive 7? What was the bottom? -2, -5. That was it. So there you go. Questions I can answer? So you can just do all the matrix stuff like that. It's fine with me. Just on your calculator, hit the buttons.
Will there be some on the test that we-
Yeah, so there won't be any on part 1. So yeah, all the matrix stuff will be on part 2 of exam 4, so you can use your graphing calculator if you want to do all the matrix stuff. Okay, I just want to show you that it does. Because it's different than what we're used to. We're in a whole new world, the matrix world, right? And so rules are different than what you're used to for normal numbers. CA is not the same as AC, which we're not used to. With plain old numbers, the order never matters, right? 2 times 3, that's the same as 3 times 2. It's 6 either way you do it. Who cares what order, right? But that's not the case when it comes to matrices. The order matters. I don't even need to do the whole problem to convince you that the order matters. Just think about the size rules, for example, right? What is C? C is a 3 by 2. Remember, down first and across. A is a what? 2 by 3. So CA means a what? 3 by 2 multiplied with a 2 by 3. That's doable because the inside numbers have to be equal. So it's okay, green light. And the outside numbers, the answer, will be a 3 by 3, which it is. So yeah, I would just type it in your calculator and do it. But look, AC is not doable, is it? A, what's A again? 2 by 3. And what's C? C is a 3 by 2. Oh, it is doable. It is doable. But the answer size will be different, huh? The inside numbers match, so that's okay. But the answer matrix will be a what? A 2 by 2, not a 3 by 3. So the answers couldn't be equal. They're not even the same size, are they? So the order matters for matrices when you multiply. They're not, anybody know that rule? What's the rule when order doesn't matter when you multiply? That's called the what property for real numbers? Anyway, it's not going to be the test. Commutative property. So when you can switch the order, it's called like you commute, you go back and forth. Right? You can switch the order back and forth. The commutative property. So matrices do not have the commutative property. You can't change the order. That's what you do in higher math. I don't know if anybody's interested in majoring in math. But after calculus, that's the kind of thing you do. You take like systems of things and you prove qualities of systems. Like they make up weird things. Like, we'll make up this blah, blah, blah world where numbers do this and numbers do that. And there's this special operation. Show that in this world things can switch order or things can do this or things can do that. And you kind of learn about how whole systems work. So we have a new system here. The matrix world is a whole new world, and it has some rules that are a little different than what you're used to. Most of them are the same.
Would it mess up your numbers too if you switched your letters like that? Because wouldn't you go down on one of them and it would cross on the other one?
Yeah, so the by hand, that's why it'd be different as well. It would do, you're totally right, Krista. The down and the cross would be different when you switch the order. Exactly. All right, so now in this one, they want me to take, I would just type into your calculator, A and B. But what's that? What's this weird thing here? What's the 4I2? What's I2? Does anybody know from their matrix experience? I2 is the 2 by 2 with ones down the diagonal and zeros everywhere else. Guess what I3 is? 3 by 3, same thing. Guess what I4 is? You get the idea. 4 ones, zeros everywhere else. Look, there's 2 well, there we go. Etc. So we have, these are called the identity matrices. So I2, I3, I4, it just means 2 by 2, 3 by 3, 4 by 4 matrix with ones down the diagonal and zeros everywhere else. This is really important in the matrix world because they are what's called the unity element or the identity element. What does that mean? The identity, I stands for identity. I2, I3, I4. They're the identity element, which means they play the role of 1, like 1 does in the real number system. Like I was saying with the higher math thing. If you do higher math after calculus, if you major in math, you prove, and one of the things you prove about a made-up system is who plays the role of 1. Who acts like the identity in that system. Now, what do we mean acts like 1? Well, how does 1 act? What does 1 do for us in the real number system? 1 is the number that you, 1 is the only lonely number. No, I'm sorry. No, that's a different, sorry. 1 is the number that anything you multiply by, you get that number back. You get identical, what you started with. Identity element, identical, you get it, right? 1, anything you multiply 1 by, you get back what you started. It's like looking in a mirror. It gives you your identity, right? That's what 1 does in the real number system. So guess what these guys do in the matrix world? Any matrix multiplied by one of those, you get the mirror reflection. You get it back. You get back what you started. They're like a big 1. You multiply any matrix by an I2 or an I3 or an I4, you get back what you started. They play the role of 1. They give you back identically what you multiplied by. So they're like a big fancy 1. Okay, so what does all that mean? So let's do this problem then. So they want me to go A, B minus 4, I2. So what I would do is I would just type A into my calculator, B into my calculator, and then, just multiply them on your main screen. And then, I would put the 4I2 right into matrix C, for example. So remember, here, let me do it more slowly. I'm probably going too quick. What is I2 again? 1's 2 by 2. 1's down the diagonal. So what is 4 times I2? Remember what happens when you multiply a whole number or any number by a matrix? Just because anything times 0 is going to stay 0, but the 4 times the 1 and the 4 times the other one will make 4. So that's 4I2. It's just 4's down the diagonal, huh? 4 times 1, 4 times 1. And the other ones are still zeros because 4 times 0 is still 0. So I would just call that matrix C. I would just put that into matrix C on my graphing calculator. So I would just put that into C, enter that as matrix C, enter A, enter B on your calculator, and then just go A times B minus C on your main screen. Does that make sense? Or I guess you could have just made C the I2, huh? And then just done A times B. Yeah, maybe you could do that. I don't know. Whatever. There's a million ways to go. Yeah, maybe I'll do that. That just looks more like the real thing. So I'll just say, all right, call that C. So call that C, and then do A times B minus 4 times C. And you'll get your answer. You cranking that out? Anybody got it? Am I expecting too fast of results? Well, they got 6 options there for us. So I'm going to move on. Grab me after if you have any trouble with that. All right, we are to here. So now they're asking for the inverse. Inverse. That's what you do in any world, any system has what are called inverses. What are inverses? What in the real number system, what is the inverse of 2? If you have 2, the inverse of 2 is a half, right? You just flip it. So that's the inverse in the real number system. Well, how do you do the inverse of a whole matrix? Well, I'm going to give you the rules. And I'm going to give you a way easier way to do it than they normally do it. So for 2 by 2 inverses, here's the steps. So if you start with A, let's just call it A, B, C, D. Step 1. Step 1, switch the main diagonal. That means this diagonal. Step 2, change the signs on the other diagonal. So you switch the main diagonal. D goes here, A goes there. Change the signs on the other one. Am I racing ahead of you? You got that? So the way, and I'm going to do it on the 9111 in a minute. Let me first show you the steps in general. So you switch the main diagonal. You just, and when I say main diagonal, I mean upper left, because that's the first entry in the matrix. So we call him the main diagonal. He's the very first entry. So this is the main diagonal. The other one's the other diagonal. So you switch the main diagonal, change the signs on the other diagonal, and then finally, step 3, divide, that's supposed to be a divide there, divide all by the determinant, and the determinant equals main multiplied minus other multiplied, main diagonal. In other words, AD minus BC. That might seem a little mysterious, but it's really not that bad. So that number, called the determinant, you divide all four of these by that number. And that's the inverse. It looks harder than it is. Those steps make it look all fancy. It's pretty easy. We'll do it in a second when y'all got it down. And then, in fact, I could probably squeeze it in the upper left-hand corner. It's that easy. So, all right, so let me go through it again. So you switch the main diagonal, change the signs on the other diagonal, and then divide all four by the determinant, which is just a number. It's just main diagonal minus other. In fact, let's take the 9. I can squeeze it up here. 9, 1, 1, 1. Okay, let's switch the main diagonal. So that'll become, I'm going to run out of room here. So I'm going to switch the main diagonal and change the signs on the other. So it'll become 1, 9, and then negatives on the other. So far, so good? I got to make that bigger. Yeah, I'm just going to do it right here. So I switch the main diagonal, change the signs on the other diagonal, and then divide all four of them by a number, which I'm going to find here in a second. Everybody good so far? So 1 and 9 switch positions. I change the signs on the other diagonal, and then I'm going to divide all four by the DET, the determinant. What is the determinant? Main diagonal, like 9 times 1. Minus other diagonal, 1 times 1. So 9 minus 1, 8. Everybody see how I got that? Main diagonal minus other diagonal multiplied. Main diagonal multiplied minus other diagonal multiplied. 9 minus 1, 8. So you divide all four of these by 8, and you're done. That's it. That's the inverse of a 2 by 4. Just switch the main, change the signs on the other, divide all four by the determinant. Main diagonal multiplied minus other diagonal multiplied. Good there. Questions on that? Are we happy about that? No questions? All good? All right, so here it is. Okay, so we're taking the 9, 17, 3, 6. Go ahead. Find the inverse, switch the main diagonal, change the signs in the other, and divide all four by the determinant. And what's the determinant? We good so far? I switched the main diagonal, right? I changed the signs on the other diagonal. And then what's the determinant? Well, it's main diagonal, 9 times 6, minus other diagonal, 3 times 17. Which is what, 54 minus 51, just 3? I think I did that right, 54, 30.
So is it always minus, or you're just doing the minus because it's the...
It's always the minus. Just like, any formula that has a built-in minus, like quadratic formula is negative b plus, it's just a built-in minus. It's always minus. Now, if the numbers themselves are negative, that'll reverse. but there's a built-in subtraction symbol to the formula.
Just because they were both negative, that worked like that. I don't get it. So are you doing it from the beginning, the 9?
It's the same either way.
Okay.
It'll work exactly the same with, yeah, good, ever hear the question? If you do the determinant, if you do main diagonal minus other diagonal here, or the original, it's the same answer either way. It doesn't matter which one you do it on. You'll get positive 3 either way. 3, 3, 3, 3. Divide all 4. What do we got? 2 minus 17/3 minus 1, 3. There it is. There's the inverse. Is that good? Now, we can do it on our calculator too, but you must be able to do this, to do 2 by 2 inverses by hand. So I will ask you to do a 2 by 2 inverse by hand on the exam. Now, there's other times where you can just use your graphing calculator also. So let's do that. Well, let's save it till we get to the 3 by 3s because that's where we don't want to do them by hand. So just make sure though that you're clear. You do have to do 2 by 2 by hand for the test. All right. Good. Can I move on the screen? We all good with that? All right. All right. So we've got 3, 2, B, B. So try that one. So this time we got letters in there. What's a determinant? Can you tell the determinant right now? Like the number you're going to divide them all by? Which is better known as B. B? 3B minus 2B, huh? Or 1B, or B. So switch the main diagonal, change the signs on the other diagonal, divide all 4 by B. Because B is the determinant, isn't it? 1B, B. And the determinant is main diagonal 3B minus other diagonal 2B. It's just B. So divide all 4 by B. What do we get? 1 minus 2 over B minus 1 and 3 over B. There's our answer. There's the inverse. Is that good? Is that okay? Getting the hang of the 2 by 2 inverses? So that one you would have to do by hand because your calculator can't do the letters. No questions? Good to move on? Let's do that. Okay, so I got this big old ugly thing. 1 minus 1, 1. 0 minus 2, 1. 6, 5, 0. And I want to do the negative 1 power is the inverse, right? Just use your calculator. So enter matrix A is that whole thing, and then do A and hit the x to the minus 1 key and hit enter. You know, after you enter matrix A and then hit second matrix names A, enter, and then hit x to the minus 1 and enter, and it'll do it automatically for you. We don't want to do it by hand. So when you got it, let me know what you got.
So when you put it in, you just hit the, when you do names A like that, and then hit the X negative 1.
Yep, just call it forth and hit x to the negative 1. All right, let's see here. All right, so here we go. So I'll go in second matrix, hit matrix A, go over to edit, enter, what is it, 3 by 3? 3 by 3, and it goes like 1, -1, 1, 0, -2, 1, 6, 5, 0. Hope I did that right, looks good. Okay, so I entered matrix A, right, then just quit out of there, and then go back into matrix mode again and name it, right? That's how you call them forth. Name A, enter. It says matrix A, what do you want to do with it? Come down here, here's the x to the -1 key right here. Hit that key, -1 power, enter. There it is, the inverse. That is the inverse. -5, 5, 1, 6, -6, -1, and 12, and -11, -2. We good with that? Is that okay on the calculator? No questions? Hey, you want to, if you want to see what they want you to do? About to say there. Let me mention this one last thing here. Do you guys know sometimes you get decimal answers on your calculator? You do the matrix thing, you get a bunch of decimals, you know, which is fine. Sometimes they'll ask you for a decimal answer rounded to 2 places, and that's all good and everything. But sometimes they'll ask you for fraction answers. Do you know how to turn a matrix full of decimals into a matrix full of fractions if they want fractions? Do you know, you hit math, enter, enter. You know about that? So to change any answer to fractions, it automatically comes out decimal. These were just whole numbers, so we didn't even need to mess around. But sometimes they come out decimals. To do it, to make that happen, you hit, on the TI-84 anyway, or the TI case, hit math, enter, enter, because what that is it changes to fractions. When you hit math, the very top button is change to fractions. Hit enter, enter, it'll take the whole matrix and make the whole thing into fractions whenever you need that. All right. Grab me after you've tried with the Casio. I'm sure has some way of doing that, and I'll be glad to go on YouTube with you. All right, now we're going to solve a bunch. We're going to solve a 3 by 3. Did we solve 3 by 3s earlier? No, I guess not. I don't remember. Anyway, I'm just going to do it with the calculator. I'm going to show you how to solve a 3 by 3 on the calculator. So here's what we do. This is a little different than what I'm going to show you, an easier way than what they're saying use the calculator, but they're going to have you do the inverse and stuff, which is fine. You could do it that way. This isn't a lot better. It's a little better. So you just type these in. And then you put the 18, 10, and -3 right in there. Does everybody see what I'm doing? This is a little different, right? You put the answers, what it equals, it's not the answers, but what it equals in there. Put that all in one big matrix. Enter that in your calculator as matrix A or whatever matrix you feel like. Save it into your calculator as matrix A. And then go back, and hit second. When you're done, hit second, quit. Enter it and then quit it. And then go back into the matrix mode. Go over to math, the math menu. Go down to RREF. Have I showed you this before? RREF, have we done this? I think we did this one time, didn't we? Reduced row echelon form. Yeah, so go down to RREF. Remember, just do what we did before to solve equations. Go down to RREF and hit enter. And then it'll put it on the main screen, and then you got to call forth which matrix. So you got to do second matrix again, and then on names, do matrix A, hit enter, and then hit enter one more time. And it'll solve it, give you all the answers. So you just put in the whole matrix, including the right side of the equal sign. Everything, the whole thing. Save it in A, and then go back into second matrix, do the RREF thing, and you got to tell it RREF on what matrix? Tell it on matrix A. Call forth matrix A. And it'll just solve it. Boom. For you. Now, we did that before, so I won't spend any more time, but grab me after class if you want help on that calculator stuff. I'm going to keep moving. All right, here we are. So we're in 11.6. Got a little half an hour. Okay, so this is solving systems. A system means more than one equation at the same time. And you've done that before, right? We were just solving 3 by 3s a second ago with our calculator anyway. What's different about these, though? What's different about this section, 11.6? Why the state of California, all the universities require me to cover this section to give you the pre-calculus certification, is because you need this in calculus because it's non-linear. What does that mean, non-linear? It's not like the ones we just finished in the last section where we had 2 equations or 3 equations or whatever. We have 2 equations, but this time they're non-linear. What does that mean, non-linear? What's a non-linear equation? That's a word you should know. It's a helpful word, not just a fancy lingo, but it'll help you to know what your teachers talk about when they say linear, nonlinear, and rules that apply to linear or nonlinear situations. A linear equation is one that's like y equals mx plus b. Meaning the picture, the graph, is a line. That's why we call it linear. You know, like a straight line. That's y equals mx plus b, which means y is to the first power and x, so it's x first power and y first power and not multiplied by each other. So that's the definition of linear. X and y are to the first power, and they're not times each other. Because if they're times each other, that really is like x squared. So that's linear. Non-linear is the opposite. So it's like x squared or y cubed or, higher powers. Or x times y, which is what we have here, notice. That's why I'm honing in on that one. That's x times y. That's really not linear, meaning the graph of x times y equals 8 will not be a straight line. It's not a straight line. So, and the second one is not a straight line either. In fact, you know what the second one is, I hope. We just had a test on those, which I'm finishing grading. They'll be here. I'll be back on Thursday. I'll give it back before you leave for the break. So Thursday, I'm a quarter of the way through grading those. I'll get them back for you Thursday. Anyway, so you tell me. It's an ellipse, good. Because x squared and y squared is a plus in the middle, huh? So that's always an ellipse. So that's an egg shape, right? So that one's an egg shape. So the top one is weird. It's not anything you've done. It turns out it's a hyperbola. I know it doesn't look like a hyperbola equation at all. Hyperbolas normally have a 1, and they totally look different, that top one. It's a weird hyperbola. It's a diagonal hyperbola is what it is. Normally the branches of a hyperbola are right, left, or up, down. It's diagonal branches is what it is. They've been turned, so it's like this and like this. My point in saying all this is how many intersection points are there then? Knowing that the 2 graphs, neither one is linear. These are non-linear. These are not lines. One of them is, an egg shape, an ellipse. The other is a couple of, it's like on half the time. Diagonal U-shaped things. How many intersections do we have? 1, 2, 3, 4. 4 intersections. Those are going to be our answers because those are where both equations are true. You with me on that? When you solve 2 equations at the same time, you're finding what points are on both graphs, meaning what are the intersection points, right? See, this point is a point on the circle, the ellipse, and it's also a point on the U-shape. It's on both graphs because it's an intersection. This point is on both graphs. This point is on both graphs. This point is on both graphs. Whereas this point here, he's not on both graphs. He's only on the egg shape. This point here, he's not on both graphs. He's only on the U-shape. This point over here is not on nothing, to use bad English. He's not on anything, right? So we're looking for points that are on both graphs because those are points that will make both equations true, right? When you're on a graph, you make his equation true. That's the membership requirement. That's how you get to be on the graph, right? All these dots that are on this egg shape make the egg shape equation true. That's why they're on there. It's like a light bright. The lights that are lighted up make the equation true, don't they? So whatever lights are on both graphs, intersection points, these 4 intersection points, they make both equations true, meaning they're the answers to the whole system. So that's a lot of talking to say that's what we're looking for. We're looking for those 2, 4. Oh yeah, and there's not necessarily 4, are there? There will be on this one. But there's not always 4. What else could an egg shape? What else could an egg shape and a couple of branches do other than intersect in 4 points? Couldn't it go like this and barely nick once here and once there? There'd be only 2 answers. Or couldn't the branches just miss entirely and there'd be no intersection points, no answers? Yeah, those are all possibilities. You could have 2 answers, no answer, or 4 answers. I think we're going to get 4 answers on this one. So we're not going to graph anything, but I'm just doing that. That's like the behind the scenes. Really, these are graphs, not lines, not linear. Graphs, and we're trying to find where they intersect. Okay, so let's do that. Let me go to a fresh screen, and we will solve them. So how do you solve 2 equations at the same time? 2 equations that are not linear. Because you know how to do the non-linear. You do substitution, addition, whatever. But 2 equations, in this case, I'm going to take number 1. I'm going to start with the easier. Solve for x or y and plug into, I'm going to do substitution method, plug into the other. So which of the 2 equations looks like the simpler one? Boys, we're having problems there. Doesn't the top one look simpler? Yeah, let's start with that one. So let's start with that top one. X times y, this will be step number 1 here. X times, these will be a lot of steps, just a warning. These are long, tedious problems. I'm only going to have time probably to do like 2, maybe 3. Probably, I got to get 3, maybe 4. Anyway, x times y equals 8. Solve for either x or y. It doesn't matter at all. Pick your favorite, whatever. I'll just divide by x. So I got y equals 8 over x. So now I'm going to substitute that, plug it in to the other equation. Right? So that's step 2 now. So step 2, plug into the other. I guess I already said that, huh? So take the 8x squared plus y squared is 72. Plug that in for y. So it becomes 8x squared plus 8 over x squared is 72, which is 8x squared plus 64x squared equals 72. Good so far? See what's happening? I solved for y in the first equation. Could have done x, doesn't matter at all. Plugged into the second equation. Now I've got an equation that only has x, so I can solve that. How do I solve that thing? What do I do to solve this equation right here now? Any ideas? I want to do something about that denominator. That denominator's a problem. What do you do, where these are going to come up all the time? What do you do when you got a denominator like that? Multiply through by it. Just multiply by x squared, all the way through, right? It's an equation, you got to do the same thing to both sides, all the terms on the left, all the terms on the right. And right here it'll cancel, and we won't have fractions anymore. It'll be much better. What is x squared times 8x squared? 8x to the 4th plus 64 equals 72x squared. Good to there so far? Everybody see what happened? I'm going to go to a fresh screen. Or maybe I can just move it up. And maybe that'd be better. We okay with what I got up here? So we have 8x to the 4th plus 64 equals 72x squared. We good there? Everybody see what I did? I multiplied through by x squared, right? To all three, canceled in the middle, multiply it on the left side and the right side. And then, what? So I got an x to the 4th equation. No surprise, I'm looking for how many answers? 4 answers, huh? All right, so how do you solve a crazy x to the 4th equation? Yeah, do the get a zero factor thing, like we normally do for higher powers, right? So for high powers, higher, third, fourth, second, third, fourth, higher powers, yeah, just get a zero factor. That's pretty much what we do. So grab this 72x squared. He's going to go in the middle, huh, because he's mid-level. So we have 8x to the fourth minus 72x squared plus 64 is 0. That good there? I brought him over. He changes signs, right? Whenever something jumps to the other side of the equal sign, it changes signs like that. We got to factor that now. You know what you should do first to make it a little easier? Is take out that 8. That'd be nice. Take out the 8. And that would be, yeah, that helped. Yeah, get that 8 out of there first. And now, with the 8 out, leave the 8 there. Now, can we factor the rest? I think so, huh? X squared. Yeah, we're looking for what multiplies to be 8, adds, remember you multiply to be the back term, you add to be the middle, right? Yeah, it's going to be 8 times 1, both minus, huh? Because 2 minuses, minus 8 minus 1 will multiply to be positive 8. 2 negatives will multiply to be positive 8, and they'll add to be negative 9 in the middle.
Is that negative 9x squared, or I'm confused?
Oh, it should be. Thank you. I messed up. You're right. Thank you, Carissa. You're right. Yeah, good. Good to there so far now. Okay, if I kind of clear some more space down here. Okay, so now what do we do from here? Yeah, good, because they're multiplied, huh? Whenever you have a bunch of things multiplied, any of them could be 0 to make that true. So you can say 8 is 0, or x squared minus 8 is 0, or x squared minus 1 is 0. Does that make sense? We're multiplying 3 things. If any one of them is 0, right? If I said, hey, I'm multiplying 3 things together, it's coming out 0, that means any of them could be 0 to make it multiply out to be 0, right? Anything times 0 is 0, right? But that first one, forget about him. He doesn't even have an x. 8 can't be 0. If it was 8x, then yeah, I could divide by 8 and x could be 0. But if it doesn't even have an x, then it's just 8 and there's no way it can be 0, huh? So just skip that part. But the other two we have to finish. So x squared, I would move it over positive 8. And then how do I turn that into regular normal x? Square root it. And what has to happen when you put a roof on the house? Up and down the ladder. Don't forget, really important in this section especially, when you put a root on both sides, do the plus or minus. Remember my goofy saying, put a roof on the house, got to go up and down the ladder. Plus or minus. So we get x is plus or minus. Simplify that, 2 root 2. On that root 8. Over here, same thing, move the 1 over. X squared is 1. Put the roof on the house. Up and down the ladder. X is plus or minus. Square root of 1 is just 1, huh? So we got our 4 answers. Notice that's 4 answers. Plus or minus 2 root 2. Plus or minus 1. 4 answers. Now, those are all x's. After all that, I'm still not done. I got to get y's that go with that. So I'm going to go up to the top of the screen one last time. So I think these are all steps you know. This is just very tedious section. Okay, so now that I have x for each of those x's, I've got to get a y. So I've got x is what? Plus 2 root 2. Let me start with that one. That's going to lead to a y value going with it. Now, what am I going to plug into? Well, didn't I earlier have y alone and it was 8 over x? Yeah, that's the best thing to plug into. Let me stop there. And I hope I'm not losing you with all the talk and the movement, right? It's time to plug in. The thing you want to plug into, the easiest thing is where you already had y alone, because you want y, right? We've got x, and we're looking for y. So what's the best thing to plug into? Where y is already alone. Y is already alone. That good? So take that 2 root 2 and just pop it in right there. What do you get? Y equals 8 over 2 root 2. Good so far. How do you simplify that? 2 goes into 8 4 times. So it's 4 over root 2. Can't leave a root in the bottom. What do? Top and bottom by root 2. Times. Get 4 root 2. What's the bottom? What's root 2 root 2? Plane 2. We good with that? Right? 2 the same root. Root 7 is plane 7. Root 11, plane 11, right? Because you have, right? Because it's really root 4, which is 2, right? Okay. 2 of the identical roots make one normal, whatever, right? And then finally, yeah, one more step. This keeps going on. 2 goes into 4, 2. 2 root 2. Woo! So what in the world was all that? That was one of our 4 answers. See how long these are? That was x 2 root 2, which led to y 2 root 2, didn't it? X 2 root 2, we plugged in back here, led, after several steps of simplification, to y 2 root 2. That is one of the 4 intersection points between these two graphs. We need the other 3. What did I say? I was going to get through 4 of these? I don't think so. All right, so now let's make it easy at this point. I just plugged in x as positive, right? Everybody with me? Positive 2 root 2. But down here we have positive and negative. Right on the bottom, positive and negative 2 root 2. What do you think is going to happen? Do I really need to go through all the steps if I plug in negative 2 root 2? It's just going to be negative 2 root 2 down here. It's going to sit all the way to the end. And the answer is going to come out when you plug in negative 2 root 2. You're going to get negative 2 root 2. All the rest of the mechanics are the same, aren't they? All the roots and the canceling and everything. It's just going to be negative, the same thing, right? Now, what about when I plug in x as 1? Well, that I'm going to have to do. Should be easier, though. So y, let me go over here. Y is, I'm just like totally out of room here. Y, let me bring it up here. Coming up over here. Y, again, is 8 over x. Keep using that plug-in. Y is 8 over 1. Positive 1, plug in positive 1, so y is positive 8. You with me? So positive 1x led to, right, here's x, here's y. Positive 1x led to positive 8y. Guess what's going to happen if I put in the negative 1? Negative 1, negative 8. There's the 4. We got the 4 intersection points between those two graphs. All of that is very valuable practice for your algebra skills, which is what you need to survive calculus. This is typical for calculus. All this algebra, this is calculus typical problem. This is what you'll see in calculus. So you got to be able to do powers and factoring and solving pretty comfortably without dropping the ball every couple steps. You have to be able to kind of flawlessly do algebra several steps, or you'll just keep missing every problem because of an algebra step halfway through. So let me really encourage you. I'm sure you wanted more to do over your spring break, right? But really doing a good job on this section, doing all 10 problems all the way out, it's exactly what you need to get yourself ready for calculus, is those kind of algebra skills. It'll help you. It'll shape you. All right, so they want you to do all those. It takes a long time just to type them in. You got to type in all those with a comma in between. Is that making sense? You want me to write it out? Then what they want you to type in, well, you can always hit the show me an example, and you can see what they want you to type in. But basically, I'll write it. They want you to type in 2 root 2, comma, 2 root 2, comma, negative 2 root 2, comma, negative, oops, I'm having trouble writing it. 2 root 2, comma, what was the other one? 1, comma, 8, comma, negative 1, negative 8. There it is. All of that is typed in as your answer. Commas between those 4 points. What's that?
If you don't do the commas, it will be wrong.
Yes, perhaps. Yeah, oh yes, it will. Yeah, you know how picky it is. All right. All right. So let's try this one. Here's number 4. Let's do this one together, and then I want to do one more after this, because there's a second type. Basically, 1 through 4 are all the same kind, the kind we just did. And then 5 through 8 will actually be easier. So this is the worst of it right here. Oh, and then 9 or 10 are calculator, but I want to show you one of those real quick so you get the buttons good. So, all right, let's try this one. So, Step one, you're supposed to notice that one of these equations is linear. One of these two would be a line if we graphed it. Which one? The second one, right? Because just x plus 3y equals 10. That's just first power on x, first power on y, and they're not multiplied together. That's a linear equation. Usually they'll give you one of the two being linear. What does that mean? That means he's the easier one. Start with him. Start with him. Right? Remember, you pick the easier one, start with it, you solve for x or y, plug into the harder one. Right? So which one would be easiest to solve for in that linear equation? Well, x, right? Because y you'd have to divide by 3, and we'd have fractions. We don't want to go there. Right? So start with that linear one, solve for x. Let's do that. So start with this guy. So solve for x. So we got x plus 3y is 10. Grab the 3y, jump it over. 10 minus 3y. So I got x alone. In the easier equation, what am I going to do with it now? Plug it into the ugly one, right? Plug it into the harder one. So step 2, 7x squared minus 3xy plus 9y squared is 91. Take that x, plug it in, plug it in. Everybody with me? Is all well there? Now that's some messy algebra. This is the kind of thing that makes calculus students have trouble, is they're not comfortable with all that foiling. They can kind of do it, but they make a mistake every 2 steps, and then that's just death to them in calculus, because every problem is like this. Not every, but many problems are like this. You got to improve to where you can do 10 steps in a row, no mistakes. No losing minus signs, no missing something in your multiplying. You just kind of have to if you want to have a happy calculus experience. So let me help. And it just takes pride. There's no mystery, no secret. It's just practice. So 10 minus 3y, 10 minus 3y. I got to write 2 of them. That's one big common mistake, right? Whenever you got a 2 on parentheses, you got to write 2 parentheses, right? I see a lot of students that think they can just square the 10, square the y. It's just 100 minus 9y squared. No, it is not. Make sure you know that. When a 2 is on parentheses, you got to write 2 of them. I remember my daughters took pre-calculus last year. I would be doing pre-calculus at the kitchen table, and they would do this many times that semester. And every time they would do that, I would go, nope, still not true, girls, still not true. And they go, oh yeah, that's right. They write the 2 parentheses, and they do the whole FOIL thing. Now my Lizzie girl acts like she never did that. Now she's in calculus. And I go, remember you used to think, she's like, I never thought that. Never. She really doesn't remember it. So anyway, it will pass. But make sure you make it pass. You got to write 2 parentheses. It'll kill you. A lot of people do it. Don't make the mistake. 2 parentheses. All right, so now leave the 7 in the front. Distribute. 100 minus 30y minus 30y plus 9y squared. Leave that 7 in the front, and then the 7's turn, he'll distribute through everything. And I haven't even done the middle one yet.
Can you distribute the 3 for the middle one?
Yeah, what I would do for the middle one is I would put this 3 and this y together first, and then distribute them. Just going to make it easier. So let's do that. Let's bring that y over. Minus right, boom, and a boom. Like good. So that'll become minus 30y plus, 9y squared. And then bring down the other 9y squared equals 91. What a mess. Is that okay? See all the signs? See why that's a plus 9y squared? Negative times negative? That's the kind of thing you got to get to where you don't mess up those signs. This is a messy business here. All right, so now distribute 700 minus 210y minus 210y plus 63y squared minus 30y plus 9y squared plus 9y squared is 91. Now I'm going to bring it up here and I'm going to gather like terms.
Do you leave it equal to 91?
What's that?
Do you leave it equal to 91?
No, we're going to make it 0 in a minute. Yeah, it's coming just like the other ones, yeah. Yeah, you know the game plan, right? It's basically gather like terms, get a 0 on the right side, factor. You know, it's kind of where we're going, just like the last couple of problems. So here we go. So what do we got? I'm going to start with the y squared. So we got 63y squared, 9y squared, and 9y. What's it? 63 and 18. What's that? 81? Is that 81y squared, I think? And then the regular y, minus 210, minus 210, minus 450y? I think, if I'm doing my numbers right. Feel free to use a calculator, you know. Be sure you're right. Main thing is not making a small mistake. Plus 700 equals 91. I don't think I dropped the ball. Did I? Does it look okay? Minus 420, minus 450. Yeah, that's right. Yeah. Is that good? Say I gathered like terms. Now we have to get a 0 on the right side, huh? Get a 0. So subtract the 91 from both sides. 81y squared minus 450y. Like that. And that's what? Plus 600, 609? Is that what it is? 609. That's ugly. Makes you wonder if you're even on track, huh? Yeah. Even 9 does. No, just 3. Yeah, 9 doesn't go into 609. Yeah, you can tell there's a trick. If you add up the digits of a big old number like 609, if you add up, what do his digits add to be? 6 plus 0 plus 9, 15? 3 goes into 15, so 3 goes into 609. So we know 3 goes into all those numbers. So take 3, now it's factor time. Take 3 out with your, use your calculator. So that'll be what? 27y squared minus 150. It's still not very user-friendly here. What is this, 203? I mean, that's still pretty darn ugly. Yeah. Not fun. We good to there? Roberto's going to finish it for us. He loves these. He'll be glad to always advertise Roberto, his services. He's available somewhere. Where is he? There? Back there. All right. So we got to, what? We got to factor that, I guess? 203? Did we mess up anywhere? Nobody sees any mistakes? So I always start getting a little concerned when the numbers get this ugly at this point. I'm hoping for nice things to happen at this point. And nothing nice has happened. Okay, so, all right, well, I guess we can try to factor, or you could do the quad if you really like the negative b plus or minus thing. Sometimes that's easier when the numbers get really ugly. I don't know. I'm looking at 27. I'm thinking, I don't know, 3 times 9. Or 1 times 27.
Usually it's closer to.
Yeah, it's usually smaller, closer numbers. You're right. Usually. No guarantees, but usually. 203? No way. That's just...
Maybe it's there's no solution.
I'm going to do the quad. Quad. When I can't factor, I do the quad. Or I look in the back of the book, but we can't do that. All right. So A, B, C, quad time. Remember the quadratic formula? So negative b. It might be able to be factored. You know how you can tell? If you crank out the quadratic formula and the square root part, the b squared minus 4ac that's in the root, if that comes out clean, like the root of 9 or the root of 16 or root of 25, something clean, that means it was factorable and you just missed it, which is fine. You've almost got it at that point. If it comes out not clean, that means it was not factorable. It was like the root of 17 or something that doesn't reduce. That means it was not really factorable, not with whole numbers. Negative b plus or minus the square root of b squared minus 4ac all over 28. Notice I'm ignoring that 3 in the front. Who cares? He's nothing, right? He can't make anybody 0. Just like we ignored the other number in the front in the last one. I'm running out of time. I get this thing done. All right, so here we go. Negative. Don't drop a sign. It's negative 150, right? Negative from the formula, negative on the 150. Question?
I think I got it. If you just want to say the time.
Did you factor it?
Yeah.
What is it?
So with the 3 on the outside, 3y minus 7,
Yeah.
9y minus 29.
7 and 29. Good job. I'll go, since I'm here, I'll already finish it up, but thank you. I'm glad somebody got it. So it's just a really hard factoring. You must be a very good factorer. Plus or minus the square root of b squared. Most people are not such a talented factorer, so this quad will be helpful for you when you can't seem to find the factoring. So negative b plus or minus square root of b squared minus 4 times a times c all over 2a. This is easier for most people on awful factoring problems. So that's plus 150, right? Everybody see the two minuses here? Right? Minus from the formula, minus from the 150. Two minuses. Plus square root of, is that 22500, I think? Minus, I have no, what's 4 times 27 times, can I borrow a calculator? Thanks. 4 times 27 times 203. 21924 all over 2 times 27, 54. Is that okay? I'm going to bring it up here. Whoops, am I erasing too much? These are long problems. All right, so what is that? Minus 2250. Okay, so 576 all over 54. Is this x or y? Was this? It's y. It's y. It's y, isn't it? It's y equals. So y equals 150 plus. And the square root of 576. This is the moment of truth. This is when you know that it's coming out clean or not. Yeah, it's nice. You're right. It must have been factorable. The root of 576 becomes 24 clean. That, as soon as you see that, you go, oh, it was factorable. I just missed it, which is fine. You'll find it right now. So now you do the two options, 150 plus 24 over 54 and 150 minus 24 over 54, which is 174 over 54. And this is 126 over 54. Guys getting that copy down? And then reduce those two fractions. Oops, I just erased everything. So this one and this one, just reduce them. What is that? This problem never ends. It's just hard all the way. It's difficult, difficult, difficult. What is, so 174 divided by 54 enter. I'm going to do math, enter. So I'm tired of playing with this thing. 29 ninths. Yeah, that's like what you were saying. I'm sure your numbers come out the same. And 126 divided by 54. So I'm just using I'm doing math, enter. Changing things to fractions. The calculator's helping me out here. 7/3. So there's our two x answers. Oh, yours, thank you. There's our two y. Those are the two y answers. Now you got to plug those awful things in for x. I got to show you one of you guys have 5 more minutes. I got gypped here by the review thing. I got to show you the other kind real quick, or things won't be good. Is that true? Yeah, we can't do that and that. Yeah, we got to show another kind. So that's y equals, and then you got to go back and plug in for x, right? You know what I mean? Can't believe how long these took. These were terrible. This is why these kind of classes took my whole life back in the day. All right, so we got y. So now how do you get x? I don't know. Where was x? Oh, x was, if you go back to x, it was, what was it, 10 minus 3y? So x is 10 minus 3, and you got to plug in the 29 ninths. And the other one is x is 10 minus 3 times 7/3. I'll do that one. That one's easy. The 3's cancel. 10 minus 7, x is 3. So that answer is 3 comma 7/3. I got that one. That's the x that goes with the y 7/3. The other one is not so user-friendly. It's 10 minus 3 over 1, right? When you have a whole number multiplying a fraction, it goes to the top, right? 3 times 29 is 60, and 27, 87 sevenths. And you can just type it into your graphing calculator and change the fractions. It'll give you the answer. Or I'll do it by hand. Put this over 1. Remember how this works? Multiply top and bottom by 70. By 7, I mean. To make it 77s. Did I mess up? Oh, that's a 9. I'm just not writing very well. Thank you. It is. That's what I get for hurrying. I was trying to show you what not to do. Don't do that. All right. So 9. That's a 90 over 9. Thank you. This is a 9. And that's 3/9. 1/3. Whew. So that's x is 1. That answer became x is 1/3. Y is 29/9. There's the two answers. Terrible. All right, we got to see one other kind. So that's really tedious stuff. I'm glad to help you. Roberto's glad to help you. Right? Come with your don't just do half of them and not be able to finish the algebra and say I don't have time for this. That's your future if you want to go to calculus, is learning that. Be glad to help you now. And I'll show you why. All right, so number 8, 5, 6, 7, and 8. 5, 6, 7, 8 are all like terms. Do you see what I mean? So 1, 2, 3, and 4 problems 1, 2, 3, and 4 were not like terms. 1, 2, 3, and 4 were not like terms. 5, 6, 7, and 8 are. See what I mean? Look at these guys. See how they're like terms? X squared with x squared, y squared with y squared. Numbers with numbers. They're like terms. Whereas if you look back at the last problem. See how on the last one, number whatever it was, 4, see how we had an x squared and we didn't have any x squared down there. We had an xy, we didn't have any xy down there. We had a y squared, we didn't have any y squared down there. We didn't have like terms. What does that mean? That means I could not have added them or subtracted them. I could not have done the addition method. But that's why I had to do substitution on 1 through 4, and it was long and tedious. But in 5, 6, 7, and 8, they're like terms. They will add and subtract together. They will combine. So just do the addition method. Do you know what I mean? Just take 2x squared plus y squared equals 3. I'm just going to do the addition method. That'll be quite a bit easier when you have like terms. And the other one, x squared minus 4y squared, move the 13 over. So it's a minus 13. Like that. That makes sense. See, I get them lined up first. Remember the addition method? So everybody seen what I'm saying? On 5, 6, 7, and 8, we're allowed to do the addition method because they're like terms. This will be easier. Remember how the addition method works? You got to make either the x's or the y's, it doesn't matter which one, opposites. Opposites. So we got to make the two x's, or the x squareds I mean, both be positive 2, well one be positive 2, one be negative 2, or you could do the y's, make one a positive 4, make one and the other one a negative 4. Make the two y's or the two x's opposites, so that when you add them, they'll cancel. Doesn't matter which one you do. How about I do the y's, since they've already got opposite signs? Whoops, I'm not going to do the second one at all. I'll just multiply the top one by positive 4. You see how I'm coming up with that? That'll make the y squared in the middle positive 4y squared, the opposite of the other y squared, which is negative 4y squared. Everybody see that? You make them opposites. So that'll be what? 8x squared plus 4y squared is 12. And then you add them up. So you get 9x squared. The y's cancel, negative 1. See, we've almost got x. See how much better this is? Divide by 9. X squared is minus 1/9. Thoughts? No solution. Do you see it? How can x squared be negative? What can you square and get negative? No way. You can do one more step if it helps you. Put the roof over the left side, over, that's a problem, the right side, and up and down the ladder. What's the square root of a negative number? What's the square root of a negative number? It's an imaginary. It's not real. The only answers in this problem are in our imagination. No solution. But that won't always happen. Normally you get an answer for x there and you plug back in and you know how to finish the plug in from there, right? Is that good? Can I show you one other thing real quick? Am I pushing in so you can make it through this homework? All right, so number 9, number 10, I just jumped to the hardest one. Basically, see it says graphing utility. These are too hard to solve by hand. You got to use graph calculator. So that means solve for y in both. Put into the calculator graph and then hit enter, then do the, after you graph, you hit second, calculator, what is it? And then choose intersection. And usually, you can just hit enter, enter, and then move near the intersect point and hit enter. Move on to the correct branch. You'll see this one has a trick. When you graph it, it ends up one of the graphs is like that. I've done this one with a student recently. The other branch is I forget. It's something like this maybe, and like this, and so here's the intersection. There's like one point of intersection right there. So when you're doing the intersect, you got to make sure your cursor is over on this branch. Put the point here, not on the other branch, or it'll never find it when you hit intersect. So you just solve for y. So this one would be y cubed is 2 minus x squared. Then you got to take the cube root of both sides. So that would be y is 2 minus x squared to the 1/3 power, right? 1/3 power on both sides. Got to put that in. The other one, getting y alone, is y equals 5 over x cubed divided by x cubed. Put that in. So that's y2. This is y1. Put them into your graphing calculator, y1 and y2. Make sure you use the parentheses right. And graph them. Get over here. Find that intersection point. That's what it wants. If you have any trouble, grab me. I'll be glad to help. Maybe I'll send out another YouTube on that. All right. Thanks, guys. Have a good day. I'll see. These are both due. They're both due on Thursday.
Oh yeah, what was the sections? 11.4 and 11.5? Is that what it was?